Hello everyone, this is Miss Salter, and this is our video on Molarity worksheet number 1. So on this one, our main equation that we are using for this, for these kind of problems, is this one right here, the M equals moles of our substance, solute, over volume of our solvent. So the amount of stuff we have dissolved in other stuff. For our purposes, we focused this unit on solids dissolved in liquids. So let me just highlight this. So this part right here, that is our main equation. Molarity, or the concentration, equals the moles per volume. Okay, so let me put this on draw with touch. So number 1, if 0.2 moles of NaOH is dissolved in liters of water, what is the molarity of our solution? Okay, so what is the concentration of our solution if we are dissolving that many moles of NaOH into a volume of liters? So this one is nice because our units for this equation is moles per liter. Okay, that's our usual one. We usually do moles per liter. So as long as you have moles per liter, you don't need to do any conversions. You can just plug everything into the equation, bing, bang, boom, and you get your answer. So here we have our plan is we have moles and liters. We're finding our molarity. So therefore we set up our equation. We plug in our numbers, 0.2 moles over 0.350 liters, and we do our math and we get 0.5714 molarity NaOH, and we can round that to 0.571. So that's the concentration of NaOH in our solution. Number 2, this one is more difficult if you notice by my plan here, okay? And I'm sticking with this whole plan thing we've been doing through conversions and everything because it's something we're familiar with. I have to have my units going into my equation as moles per liter. I am given my information in grams and milliliters, so I have to convert it. So I'd have one conversion here, which is going into my formula weight. I get from my grams to my moles. That's this one, the 3.41. So if I take this, so this part here, grams per mole, is this one here. Okay, grams per mole. And I get my moles of NaCl. Then I take and I need to find my milliliters per liter. That's this one here. Okay, 1 liter equals 1,000 milliliters, so I just make sure if I'm going from milliliters to liters, I have the milliliters on the bottom so they cancel out. And then what I'm doing in this bottom one is I'm doing my actual equation, and of course I didn't write it down. So our equation here is moles. Let me do the red. Moles. And then over my liters. Oh, that shifted. Oh no. we go. Over equals, and then that equals my molarity. Okay, because that's my concentration. So I take the moles from the first part, I put that over the liters in the second part, I get my concentration of salt solution, NaCl solution in my third part. Okay, so here I had to do 2 conversions before I went into and did the actual equation. Okay, next. Number 3, how many moles of solute do I need to make so many liters of a certain concentration or molarity of a solution? So here I am given my molarity, my big M, and I am given my volume. I have to do a little bit of algebra, and I come up with the number of moles of MgOH2. And I can just leave it right there because they're asking me how many moles. So I can leave that right there. That works out 15.75. Using the same equation, just finding something different. Before we were trying to find molarity big M, now we're trying to find moles. Next one. Number 4. How many grams of solute make, and I am sorry about that because when I did this, I had some white out there. That is a 2.1. So let me just put this in here. This is 2. Oh, you funny bunny. 2.1, and this is liters. Okay, so in this one, they're asking me for how many grams. They give me liters, they give me molarity. So I'm good to go. As far as that goes, I don't need to convert anything to start with. My plan starts with molarity and liters. It goes to moles, but then I have to do a conversion. It wants me to convert it into grams, because if I'm making the solution in the lab, I don't necessarily say, oh, well, I'm going to put this many moles of my solid on my scale, and my scale does not read in moles. It reads in grams. So I have to then change it from moles of aluminum nitrate to grams of aluminum nitrate. I did my little chart there. So I have my formula weight, and then went from there. I gave you the formula weights on the worksheet, so that made it kind of nice because we've tested that. You guys know how to do it. And so I wasn't going to, trip you up on some silly math error or something like that trying to do your chart. So I was more concerned with that you could do this part, which is given the molarity and the liters. You can find the moles of your solute, the stuff that goes into your solution, and then find the grams of that. So we have our molarity equals moles over volume. You change it because you're trying to find the moles, plug in your information, then you take that moles result and you multiply that by the grams per mole, and you get the answer. Okay. And 5 is the same as 4. Same thing. Given molarity in liters, you're trying to find moles, then you have to go to grams. So you do your equation first, plug it in, find the moles, then you change the moles to grams using your formula weight, and you get your answer. So these are 5 really good model problems along with the examples to use to do any calculations you might need to do using molarity in the future. And I hope this helps, and have a good